Welcome to another episode of our mathematics class. And today, based on popular demand, we will be talking about calculus. And in calculus, we have two subtopics in that topic. We have the differentiation, while the second one is the integration. Whereby it's just like when we talk about sequence and series, we have arithmetic progression and what geometric progression. That's two in one what two in one topic. Now for calculus, we have differentiation and we also have integration. Now you need to understand differentiation before you can say you want to dive into integration. Even though they are of different method, the way you solve this is different from the way you solve this. Just that one will give you a clue to how to solve the other. It's just like when we talk about permutation and combination too. Without understanding permutation, you might not really understand combination. Not in most cases though. So now for differentiation, we have what we call, when they say differentiation simply means differential, that is change in something over change in the other. So most times we use dy over dx, that is change in y over change in x. And in this type of scenario, this is when the equation is maybe y equals to maybe 3x plus 1, or and as long as it has an unknown which is x in the equation. But what if it is okay, y equals to 3b plus 1? Then your differential calculation is not going to be dy over dx, but what? Dy over db. That is change in y in respect to it to what? To change in b. So that is how you will solve that. So you really need to understand that. So when we talk about dy dx, it's still the same thing as saying dy dx, that's dy over dx. It's still the same thing as saying y prime, and it's still the same thing as saying f prime of y. This is still dy dx, and it's still the same thing as saying slope. Many would have seen this in physics when they ask you to calculate the slope of a graph, that you have to say y2 minus y1 all over what x2 minus x1. This is still the same thing as what dy over dx. And the last one is tan theta still represents dy over dx. Tan theta still represents dy over dx. So let's move forward. In differentiation, the first method they teach us is first principle. How you solve using first principle. First principle. How can we solve a question by using first principle? Example one. Let's assume we are told that x equals to and y equals to x raised power 2. Then to find dy over dx using the first principle. Listen, to find dy over dx using the first principle, it means that you would say, okay, y plus dy definitely will give you x plus dx. X plus dx. Now when you have this, you come back and say, okay, y plus dy equals to, this is the initial grant that okay, y plus dy must always give you x plus dx. Now this is y, it still remains itself, but the x, does it represent the x? No, the x is having a square here, which means that your solution is going to be x plus dx square, x plus the x square, because the x is not standing on its own. So the next thing is you need to expand this. That's y plus dy equals to what? When you expand this using binomial expansion or simple expansion, you have x square plus 2x dx plus dx square. Having done this, the next thing you need to do is you take this minus y, and you take this y towards the other side, then it turns to minus y. So look at it. Then we have what? Dy equals to what? X square plus 2x dx plus dx square minus y. Having done this, go back to your question. Your question says what? Y equals to what? X square. So instead of writing y, you just put in your x square. That's dy equals to what? X square plus
2x dx plus the x square minus what? Minus x square. This x square minus x square will cross each other. So you'll be left with what? dy equals to what? 2x dx square. 2x dx plus dx square. 2x dx plus dx square. Now, having done this, what's the next thing you need to do? You need to divide both sides by what? By dx. So when you divide all sides by dx, then you have what? dy over dx equals to what? 2x plus what? Plus dx. So we do our limit function to be what? As the x tends to what? To 0. So it means anywhere you see dx, you put in what? 0. So at the end of the day, dy over dx will now be what? Dy over dx will now be what? 2x plus what? Plus 0, which is what? 2x. So for those that know how to use the major formula for calculating this question, we will get there very soon. But when you are told to use first principle, this is how to solve it. Let me quickly take another example, then we'll move to the next one. Here is another question. Y equals to 3x plus 5. For those who know how to use the faster method, you will know that what? Dy dx equals to what? Equals to 3. Now let's use the first principle method. Using the first principle method, using the first principle method. So what do? You say what? Y plus dy equals to what? X plus dx. I'm only taking my time so that people can understand this. Now, when you do this, you know that your y plus dy still remains. Now, what is your x? Your x is not standing on its own. It is being multiplied by what? By 3. Which means it will be what? 3 into bracket what? X plus dx, then plus the last one, plus 5. Because 5 does not have x, which is unknown, although it has x is per 0, but it doesn't have x here, then we can still put the plus 5. So at the end of the day, you have what? Y plus dy equals to what? 3x plus 3 dx plus what? Plus 5. Are you with me? So you can easily see what? This y will come to the other side. So we have what? Dy equals to what? 3x plus 3 dx plus 5 minus what? Minus y. Now, what is this minus y? Minus y is the same thing as saying what? Minus 3x plus d. So you can easily say dy equals to what? 3x plus 3 dx plus 5 minus 3x minus 5 plus 5. So at the end of the day, if you kind of open the bracket, you will see that this one and this one will actually cancel this. So you have what? Your dy to be what? 3 dx. Now, if your dy is 3 dx, divide both sides by dx. So that would what? Dy over dx equals to what? 3. This time around, there's no need to say as dx tends to 0 because you have easily calculated your answer. So now let's talk about 3 subtopics or 3 to 4 subtopics in this differentiation. What is the first one? So there are four subtopics in this differentiation. We have the function of function, which majority call it J rule. We have function of products, we have function of quotient, and we have what? Trigonometric function. Now I'm going to take my time explain each of these one after the other. If you don't understand function of function, you cannot really understand function of product. You will see the beauty of mathematics that without this step, you might not be able to go to the other step. But if you are lucky to go to the other step, will you be able to go to the next step? That is why it is always good in mathematics. You learn from the basics, from the scratch. As understand what function of function is, move to this and move to this, this is what we will be doing in the next video. I'm not sure it will contain this video. Before I talk about the first one, this is just the general formula for differentiation. If you have y equals to what? X raised per n, then you are saying dy dx is equals to what? Is equals to the power multiplied by the coefficient of x here. And the coefficient of x here is what? Is 1. So n times 1 will give you n. Then you subtract 1 from the power. So the number, the base still remains then you subtract 1 from the power. So indirectly, if you have something like this, just like the one we did, first principle, we have y equals to what? X raised power 2. We said what? Dy over dx will be what? 2 times the coefficient of x is what? Is 2. Then x, you subtract what? 1 from the power. That's 2 minus 1. And 2 minus 1 is what? 1. And x is power 1 is what? Is still the same thing as x. So that's how we're able to have this kind of solution. So using the first principle, that is, if you are doing WAEC that require, if you are doing any external exam that requires you showing your working, then you have to show your working. There are always faster routes to solving mathematics questions. Now, I haven't talked about the general formula. Now let's talk about the first one, which I said function of function. Function of function is very simple. Like I said, it's the same thing as saying chain rule. Function of function is the same thing as saying chain rule. And how does it work? Okay, the formula is dy over dx equals to what? Du over dx times dy over dx. Sorry, times dy over du. You see that u will cancel each other, then you have what? Dy over dx. But that's not what we are trying to say. Now, function of function means that we have a function inside another function. And when you're having a function inside another function, what does that imply? Example 1. Let's assume we have y equals to what? 3x squared plus, let me use negative now, minus 5x raised power what? Raised to power 4. Now, you will agree with me that initially or normally, this is actually a function, right? This should have been the normal function, or the only function they would have given us. But now, they are now putting that function into a particular power, which means that this power is a function of what? Of this. Do you understand the meaning of function now? Now, it means a power, or we have another function present in the main function. Now, in solving this, what do you say? You say, you have to be mindful of your formula too. You see that they wrote u, x, y, z. Where are these coming from? Normally, we know this is y, this is x, so we have y and x. So that means that u is representing something. So you will now say, let u represent the main function we have, which is 3x minus 5x. Do you understand? So that our y, our normal y will now be what? The u that we just replaced, raised to power what? Raised to power 4. You are good to go. Now all you need to do is what? Du irrespective to what? To dx, which is the first one. Anything you get, you multiply by what? Du irrespective to what? Dy. Do you understand? So now let's come here. Let's do du dx. Du over dx equals to what? When you differentiate this, you don't need to use long first principle method. Just do the normal formula I gave you here. All you need to say is what? 2 times what? 3, 6, which is 6x raised to power 1, which is 6x, minus what? This one has the power of 1. So 1 times 5 is 5, so minus 5. 1 minus 1 is what? Is 0. X raised to power 0 is what? 1. Any number raised to power 0 is what? Is 1. So any number raised to power 0 is 1. So then we have this. Then let's talk about dy over du. Dy over du is straightforward, which is what? 4 multiplied by the coefficient of u, which is 4 u raised to power what? Raised to power 3. You subtract. So all you need to do is what? Bringing the formula back, which is dy over dx equals to what? Du over dx times dy over du. Then you have what? This multiplying this, which is 6x minus 5 times what? 4u raised by what? 3. 4u raised by 3. So you are not done, because you replaced the u with a particular function. So you need to bring back that function, which is this. So at the end of the day, you have what? Put this inside bracket 6x minus 5, then times 4. You know the 4 can now come outside here. That's why you need to be careful in solving. Then the 4 is already outside. Then times what? Times u. What is u? 3x squared minus what? 5x. Always power what? Always power 3. So this is the solution for function of function. That is when you have a function inside another function. How about when the power is negative? Let's give an example. Y equals to x raised to power 2x. What is dy dx? Just like this, the way you have been solving it. The power is minus 2, multiplying the coefficient of x, which is what? Minus 2. Abi? Then we have what? X is per what? Some people would have said x is per minus 1, but you are wrong. All you need to do is what? You subtract 1 from the power, like I said, which is minus 2 minus 1. Minus 2 minus 1 will give you minus 3, which at the end of the day, you can rewrite this as what? Minus 2 all over what? X is per 3. Minus 2 all over what? X is per 3. So you need to learn every day. So let's treat another question in function of function. Then we'll move to function of product. Here is a question in JAM. So we are going to treat that now. So if 2x plus 2 always per 3, this time around let's change it to minus 4. Now solve this. What do you do? The first thing is, this is a function. You need to be able to interpret what kind of function is this. Okay, this is a function of function. This is a function of function. So what do? You say, okay, let u equals to what? What is in the middle? 2x plus 2. So that your y will be what? U raised by what? Minus 4. You don't necessarily have to use u. You can easily say you can easily say let a equals to this, but take note that the letter you have used here, when you are going to use the formula, it is going to be what? It's going to be dy over dA times what? Times the a over dx. So you have to be mindful of that. But most times we make use of u in u and v in differentiation mathematics, and there are times that we make use of w too. That's if we have three variables. So let u equals to this, so that y will become this. So the next thing is what? Du over dx, which is this u irrespective of this x is going to be 2. Take note that when you are differentiating a constant, a number that has no x or that has an invisible x is going to be 0. Actually, there is actually an x here. And where is the x? The x is actually 2x raised power 0. But because we know that 2x raised power 0 is going to be what? 1. So that's why we always write what? Just the constant. But let's assume we write the x here. 2x raised power 0. And you want to differentiate this. That will be what? 0 is 0, the power times what? The coefficient of x, which is what? 2. 0 times 2 is what? 0. You don't need to say x raised power what? Minus whatever. Because 0 times any number is going to be what? 0. So that's why the constant will not reflect anymore. But the differentiation of 2x is what? Is 2. Why the differentiation of dy du is going to be what? Is going to be minus 4u raised power minus 5. Some people would have said minus 4u raised power minus 3. Then you are wrong. Be mindful. It is using the power to multiply the coefficient of u, then subtract 1 from the power. And the power is already negative, and you're subtracting another negative from the power. Definitely, it is going to be the sum of the negative. That is minus 4 minus 1, which is going to give you minus 5. So your formula is what? Dy over dx equals to what? Du over dx times dy over du. So how do you do that? What's your du over dx? 2. Multiply by what? Minus 4 u raised by what? Minus 5. All you need to do is what? Okay, this negative will come outside and meet 2 because minus. Then this 4 will come outside and multiply with what? With 2, which is minus 8 into bracket what? What is your u? Your u is what? Is this 2x plus 2 always by what? Minus 5. So this is your solution. So in case you want to do further arithmetics, further arithmetics, you can easily say, okay, your final answer is going to be what? Minus 8 all over what? All over 2x plus 2 always by what? 5. That's if you are changing, if you are bringing the minus, you are taking away the minus and you are bringing it down. So the next subtopic is function of products. And function of products can actually be from function of function, because majority of the questions you have solved are actually from, or majority of the questions in function of function are actually found in function of product most times. How do I mean? For function of product, from the word product, it means you are multiplying two functions together. Function A multiplied by function B. What is the formula? The formula is what? To find the dy dx is going to be u dv over dx plus v du over dx. Some can say the formula is du over dx equals to what? U v du over dx plus dz. Just take note that because it is a positive number, so it will not really have any effect. But if it is a negative value here, then and you're interchanging it the other way, you are going to actually, it is going to affect your calculation. Now, we have this formula to be the formula for function of products. How do you know when a question is function of products? This is it. Question 1. If y equals to 2x plus 1 and 4x squared minus 2. Definitely, you agree with me that this function is multiplying this other function. Then you are good to go. What do you need to do? All you need to do is let this first function be u, which is 2x plus 1. So that the other function, which is this, 4x squared minus 2, will be v. Since you have done that, then you look for what? Du over dx. Du respect to dx is what? Is 2. And dv over dx is what? Is 8x. You need to understand that. Now, having gotten that, all you need to just do is go and input this, and this into your formula. Most times, should in case you are doing any external exam that warrants you taking along your four figure table, I guess this formula is actually at the back of the four figure table. And there are times that you need to actually cram the formula. So you don't need to cheat, but just know that okay, with this we multiply. Or you say that okay, the dy dx, which I mean this formula, is still the same thing as dy dx, it's still the same thing as saying u v prime plus what? V u prime. And remember, what did I call prime? I said something prime is still the same thing as what? Differentiation of that thing. So u v prime means that what? Ordinary u multiplied by what? The differentiation of v, which is the v dx, plus v, ordinary v, multiplied by the what? The differentiation of what? The u dx. So you can easily cram this formula or you cram this. So there's nothing bad in cramming. So having done this, just input them to your formula. So that will be what? To find the y dx, it will be this, which is u. What is u? U is 2x plus 1. 2x plus 1. You are going to multiply by the v dx. What's the v dx? This is the v dx, which is 8x. Right? Then plus, what is v? V is what? 4x squared minus 2 into bracket what? Into bracket 2, because the u dx is what? Is 2. So you are not done yet because you can easily multiply this. So 8x can open this bracket, that will be 16x squared plus 8x, then plus, then this one will multiply this, that will be plus 8x squared. Are you with me? Minus 4 plus 8x squared minus 4. So you can easily collect the like times because x squared x squared. So that will be 16 plus 8, which is 24x squared plus 8x minus what? Minus 4. In case you do not even see your answer like this, how else can you see your answer? You can see your answer as this: 4 into bracket 6x squared minus 2x minus 1. So that will be your final answer. What we are doing now is, when we are comparing function of function with function of product, when you are asked to solve this minus 5x raised to power 4 plus 2x all raised to power 2, you can easily agree with me that it means that this function is multiplying itself twice. That is, this function is repeated twice, which is this multiplied by the same function. Are you with me? Now, sorry, this the question I gave might be so complicated. I'm meant to actually give a simpler question, but let's assume this is it. Now, you agree that this is a function. This is a function inside another function. Why this one is product function? That is, this function is multiplying this other function. You will see that it is going to give us the same answer. What do we say about function of function? Let u equals to what? What is in the middle? Minus 5x 4 plus what? Plus 2x. So that our y will be what? U raised power what? U raised power 2. U raised power. So our du dx will be what? When you differentiate this, you will have minus 20 x raised power 3 plus what? Plus 2. So then our dy du will be what? 2u. So you need to do is what? Multiply these two together, because our dy dx equals to what? Dy over du times du over dx. So you're just multiplying these 2u times this, which is minus 20 x raised power 3 plus 2. So you can easily say, okay, minus 20, we multiply this, we multiply this 2, which is minus, or let's do it this way. These 2u, let's do it this way. That will be, what does this u entails? What does this u carry? We cannot easily multiply these 2 times this minus 20, because of what? The minus 20 is having a plus 2, which means we are expected to actually put this inside a bracket. So you need to use what? 2u. What is u? I'll use what? Minus 5x raised power 4 plus 2x, then minus 20 x raised power 3 plus 2. Now, you will see that I almost missed the question. That is one thing about this kind of calculation. You must make sure you are doing the right thing. If it warrants you putting a bracket, put it in a bracket so that it will not get you confused. Can you see the solution for this question? Now, let's use the function of product method. Now, let u equals to what? This, and v equals to this. I don't need to write it anymore. So that our du over dx, you know your du dx is still going to be dv dx, right? Because they are the same um, value. So when you differentiate this, it's going to give you this. When you differentiate this, it's going to give you this. So that will be minus 20 x power 3 plus what? Plus 2. So all you need to do is what? What is the formula? Dy over dx equals to what? U dv over dx plus v du over dx, or uv prime plus vu prime. So what are we doing? So our dy dx, our dy dx is going to be what? U, which is this, multiplied by what? One of this. That's minus 5x raised power 4 plus 2x, multiplying minus 20 x raised power what? 3 plus 2, right? Then plus the other one, v, which is this, minus 5 x 4 plus 2x, multiplying the other one, minus 2 20 x raised power 3 plus 2. Do you understand? Now, because it is the same, how would I put it? It's just like when you have a plus b, and you also have a plus b. Definitely, you can easily say it's what? 2 into bracket a plus b. That is what is happening here. All you need to do is add the coefficient together and bring out the number. So what I did here was what? Adding the coefficient of the one of the a plus b here, which is 2. Then if I expand this, this will be 2a plus what? 2b. Then if I want to add this normally, that's what? A plus b plus a plus b. That's what? 2a plus 2b. So now, that means that this will at the end of the day give me what? 2 into bracket, one of this. You remember factorization, which is what? Minus 5x raised power 4 plus 2x into bracket what? Minus 20 x raised power 3 plus 2. It's not the same thing as this. Now you will see that function of function and function of products will actually give you the same answer. If we actually give you the same answer. So this will take us to the last subtopic. It's actually meant to be two subtopic more, but I don't like a situation whereby I bombard my students with lots of explanation on a single topic. So The next one I'm going to is function of quotient. Function of quotient implies that A divided by B. Let's take it one after the other. Function of function is A raised to power B. That is a function having a power. Function of product is A times B. That is two functions multiplying each other. Like I said, it can be more than two functions. Why quotient is what? A over. That is a function dividing the other function. And what is the formula? Here is dy over dx equals to v du over dx minus u dv over dx all over v square. You need to be careful. This is vu prime minus uv prime. It's different from the product. The product is uv prime plus vu prime. No matter how you write the product formula, it does not matter. It's just like when you say a plus b, it's the same thing as b plus a, of course, yes. But when you say a plus b, when you say a minus b, it's the same thing as b minus a. This is wrong. So this is what is happening right now. So the formula for function of product can be interchanged anyhow. While for function of quotient is what? V into what? Du over dx minus u into what? Dv over dx all over v square. Now let's give a question. Let's give an example. And this time around I will try to give a simple example so that I won't stress I will not stress our audience. So let's assume we have y to be y to be 2x squared minus 1 and this one to be what? X minus s raised by 3, or let's use minus s raised by 2. Now how do you do this? All you need to say is what? Let equals to what is at the top, which is 2x squared minus 1. Then v is what is at the bottom, x minus what? S raised by minus 2. So I haven't done this. What is du dx? What is du over dx? Du over dx is what? 4x. Y dv over dx is what? This one will be 1. Then this, you will say minus, then differentiate this, minus 2 multiplied by coefficient of x here is 1. That will be what? Minus 2. Can you see what I'm doing? Then you subtract 1 from the power, which is x is power minus 2. So at the end of the day, you have this one to be what? 1 plus 2x is power what? Minus 3. You really need to be careful here. Pause the video, try to understand what I've done there. So moving on to the next thing, then you just put your arithmetics. Okay, these are these, multiplying this. So let's do it. So our dy dx will now be what? V, which is this, x minus x is power minus 2, multiplying what? Du dx, which is what? 4x. Then minus, what is our u? Our u is 2x squared minus 1, multiplying our what? Our dv dx, which is what? With v multiply with u multiplied by what? The v dx, which is this, then all over v squared. So having gotten this, normally you will not be given this kind of complex question, but because I tried not to bring a difficult question, as soon as I find myself bringing out this. But let's not just stop there. Let's use this 4x to multiply this. Let's multiply. That will be what? 4x times x is 4x squared, right? Then minus 4x times x is power minus 2. How do you solve that? That will be x is power minus 2 multiplied by what? 4x. 4 times coefficient of 4 of x here, which is 1. So that's 4. Then x raised by what? Minus x raised by what? Minus 2 plus 1. Because coefficient of x is what? 1. That will be what? Minus 1. So in case you are multiplying, that's how you do it. 4x raised by minus 1. So you've gotten that. Then minus, if you want to do this, you need to expand this. So that is going to be a long process question all over What's your v square? You still need to expand. So, but questions do not come like this. That is going to be difficult for you to expand. Now, that is all for function of function, which is chain rule, function of product, function of quotient, first principle. Now, what you move next to, which is maybe in the next video, is going to be trigonometry function. Trig. We talked about trig, how you can apply trigonometry function into what? Function of function, function of product, and function of quotient. But ahead of the class, go and study, go and study differentiation of each trig. When they say what's the y dx of sine x? The y dx of sine x is cos x. The y dx of cos x is what? Minus x. What's the end of tan x? That will be success. So you need to just read more on that ahead of the next class. So thank you for watching. Thank you, and don't forget to click on the subscribe button. Thank you, and God bless.
Price, trusted authenticity, anytime, any day.